Good morning, students. Today we are going to start a new topic in physics, that is heat transfer. So concentrate yourself. This is important topic. Thermal energy is the total kinetic energy of the molecules in a body. Very important line. Heat transfer takes place only when there is a difference in the temperature. And other very important point. Heat is transferred from high temperature region to low temperature region. Example is bodies A and B are in contact. Body A is at high temperature than body B. And so A loses heat at a rate higher than the rate at which it absorbs heat from B. This causes a temperature drop in body A and an increase in the temperature in body B. Finally, the two bodies have the same temperature. The three methods of thermal energy transfer is conduction, convection, and radiation. The topic which we are going to read now, the radiation. Radiation is a method of heat transfer whereby heat energy is transmitted from a hot object to another in the form of the infrared. This is the definition. This is the concept. This process does not require any medium. Another very important concept. It can also take place in vacuum. Infrared radiation is emitted as well as absorbed by all objects. The thermal energy from the sun reaches the earth by the process of the radiation because the light energy has to pass through the vacuum. That's why the hotness of the sun comes to the earth through the radiation process. A hot object becomes cooler when heat energy is released by radiation to its surroundings. When the emitted radiation reaches other objects, some of the heat energy is absorbed. This makes the molecules of the other object vibrate faster, so they become hotter. Different objects emit or absorb different amounts of the radiation. There are three factors which affect the rate of the energy transfer by radiation. So very important question. Very important concept. This normally comes in the paper. The first factor is color and texture of the surface. Dull, black surfaces also absorb faster. Bright, shiny surfaces also absorb slower. The next factor is surface area. Large area absorb more and small area absorb heat slower. The temperature, higher the temperature, more heat will be absorbed, and lesser the temperature, less heat will be absorbed. So these are three factors: color and texture of the surface, surface area, and temperature. These are three factors which affect the radiation. Examples of everyday applications. The cooling fins on the back of the refrigerator, in a car radiator, and on a motorcycle should be dull black so that they will radiate away heat energy at a faster rate. Brightly polished kettles and teapots do not lose much energy by radiation. They can keep the water inside warm for a longer time. The solar panel has a dull black surface to absorb more heat energy from the sun. A firefighting suit needs bright and shiny outer layer so that it is slow to absorb heat energy from the fire. People living in the hot weather prefer white clothes and paint their houses white to reduce absorption of the heat energy from the sun. A vacuum flask keeps hot liquid hot and cold liquids cold. Factory roofs are sometimes coated with aluminum paint. This reduces absorption of the heat during the day and reduces radiation during the night. So a fairly steady temperature is obtained in the factory. In the same way, petrol storage tanks are sprayed with silver paint to reflect the sun rays. A puzzle is here. In a barbecue party, it is common to see people wrapping food in aluminum foil and placing it near the fire to cook. This is a good way to avoid having the food burned. If you have examined the aluminum foil carefully, you will notice that it has a shiny side and a dull side. Which side should be on the outside when you use aluminum foil to wrap food for cooking in a fire? So, the dull surface should be inside. A question is here. The diagram shows a vacuum flask and an enlarged view of the section through the flask wall. The main reason for silvering is to reduce heat transfer by. So here is a stopper. This is silvering surface, which is inner surface. This is vacuum between the two surfaces. This is liquid and this is silvering surfaces. So the answer is B part, radiation only. The purpose of the silvering is to reduce heat through the radiation only. A shiny surface is a poor absorber of the radiant energy. A dull surface is a good absorber of the radiant energy. Two identical metal plates are painted. One matte white and the other matte black. Here is a matte black metal plate. Here is a matte white metal plate. Here is an electric heater. These are placed at an equal distance from the radiant heater as shown. The heater is turned on for 5 minutes. Which metal plate absorbs more energy and which plate emits more energy in this time? The answer is A. The dull colors, the black color is a good absorber as well as a good emitter. Black of the dull surfaces are both good emitter and good absorber of the radiant energy. Exam tip is white or shiny surfaces are both poor emitter and poor absorber of the radiant energy. Another question is here. The diagram shows a metal saucepan containing water and is placed on a hot plate. There is a hot plate on which saucepan is placed. After some time, the air at point X also becomes hot. This is the point X. What are the main ways by which heat travels from the hot plate through the base of the metal saucepan, through the water and through the air to point X? So A is the answer, through the base of the saucepan through conduction, because heat will be passed through colliding the particles with each other, and through the water through convection, because hot water will get less dense to rise and colder water being more dense will sink. So convection current will take place within the water. And through the air, again convection current will take place because the air near to the surface of the boiling water will get less dense, will rise, and more dense air will sink. So convection current will take place in the air above the layer of the hot water. So A answer is conduction, convection, conduction. Conduction will take place through the base of the saucepan, convection through the water, and convection through the air. For solids, there is no convection. At what speed is heat transmitted by radiation? So the speed is 3 multiplied by 10 raised to power 8 meter per second, the speed of the light. This topic is kettles. Since shiny surfaces are bad emitters of the radiation, a shiny kettle can keep liquids warmer than a black kettle for a longer time. This is the figure. In addition, since shiny surfaces are bad absorber of the radiation, shiny containers can keep a cold liquid cooler for a longer time than black containers. Greenhouse. A greenhouse is useful in helping certain plants grow better by trapping heat inside. On a warm day, infrared radiations from the sun passes through the glass of the greenhouse and is absorbed by the soil and plants inside. The soil and plants therefore becomes warmer and they emit infrared radiations of the longer wavelengths. These longer wavelengths of the radiation are unable to pass through the glass, and so the heat is trapped inside the greenhouse. This causes the temperature inside the greenhouse to rise, and this is good for plant growth. The global greenhouse effect. The Earth's atmosphere behaves like a greenhouse. The Earth's radiation easily passes through it and is absorbed by the Earth's surfaces. As it warms up, the Earth re-radiates energy of the longer wavelength. This becomes absorbed by the water vapors, carbon dioxide, and other gases in the atmosphere. The warm atmosphere in turn radiates back to the Earth, so making it warmer than it would be otherwise. However, over the past century, the amount of the carbon dioxide has increased, mostly from burning coal. Indeed, the concentration of the carbon dioxide is expected to be doubled by the end of the next century. This will increase the greenhouse effect and consequently the average temperature of the Earth should increase. In all probability, this will lead to the shrinking of the world's ice caps with a consequent rise in the mean sea level. In addition, there will almost certainly be changes in the world's wind and weather pattern. Finally, it may help to delay or ward off the possibility of another ice age. Left is the picture of the summer 1917 and right is the picture of the summer 2005. Ice caps are melting. So this was the lecture. Read it again very carefully and make your notes. Thank you so much.